Alright, boys and girls, it's time to play everyone's favorite game show. Name your favorite notation. I know what you're thinking. It's connotation. No, that's wrong. Is it sannotation? No, that's wrong. What is the right answer? The right answer is scientific notation. That's right. Your favorite, my favorite, everyone's favorite type of notation. Scientific notation. Now, scientific notation is very stingy. He is very specific about the way he looks. Okay, he has a certain way when he comes to work that he wants to look. So here's what scientific notation needs to be. Scientific notation needs to have two things. Number one, it needs to have a number out in front of the decimal, which we'll talk about in a minute. Then it needs to be multiplied by a power of 10. So when we write numbers in scientific notation, here's my decimal point. It is very important that you only have one number to the left of that decimal point. So, for example, if I wrote 12 to the left of that decimal point, that is no longer scientific notation. He's angry, his clothes don't match, he's not probably going to go to work that day. So, one number to the left of that decimal point. Now, this number can be any number between and including 1 and 9. So, it could be a 1. Okay? Oops. It could be an 8. It doesn't matter, as long as it's one number to the left of the decimal point, followed by a multiplication symbol. Can be a dot, can be the x for multiplication, of some form of power of 10. So it could be 10 to the exponent 3, could be 10 to the exponent negative 4, as long as it's multiplied by some power of 10. So you can see here is a perfect example of scientific notation. We have one number to the left of the decimal point. It does not matter how many numbers are to the right of the decimal point. You can have as many as you want. Okay, sometimes you have a few, sometimes you have a lot. Okay, and again, it's multiplied by 10 to the power of 8. Okay, so what we're going to do is we're going to look at 4 parts to scientific notation, going back and forth between scientific notation and standard notation. When I'm talking about standard notation, I'm basically talking about the way you normally see numbers. For example, if I was talking about 147, well, I would write 147. That's standard notation. What you're used to seeing is a standard. That is standard notation. Scientific notation, again, would be written as the following. Okay, so the first thing we're going to do is we're going to take a look at some numbers, and we're going to kind of continue the theme that we talked about yesterday in writing these numbers in scientific notation. So we have this number, 4,520,000, and I want to write this in scientific notation. So we're kind of going to begin with numbering underneath these numbers. So I'm going to start again with 0 here. So go ahead and write that down on paper. I'm going to go 1, 2, 3, 4, 5, 6. Now, I know what you're thinking. You're like, oh my God, Mr. Gateo, you're going to make me write all these numbers underneath these numbers every time. No, that's fine. Once you kind of catch on and you can kind of count in your head, I can sit here and go, okay, 0, 1, 2, 3, 4, 5, 6. I don't need to write them down. But just for some examples, let's do this just for the first couple. So I know I'm coming out to the 6th digit here. Okay, so what that means is you're going to now write the last digit, which is this 4. I'm going to write 4, put the decimal point, 5, 2. As soon as you hit this string of zeros, you no longer need to keep writing numbers. Now I'm going to write times the power of 10, and whatever this number is under your last digit now becomes your exponent. So 4.52 times 10 to the power of 6. Okay, so let's take a look at a couple more examples. So here you can see these are in miles the distance certain planets are from the sun. So here we have Mercury, that's 57,900,000 miles from the sun. So I want to write this number in scientific notation. So first thing I want to do is I'm going to start counting below. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, so now I'm going to write this first digit. I can do it over here. 5. Decimal point always comes after that first number. So if you need to, you can just put a line through there because that's going to separate it. That's where the decimal is going to go. So there's always one number to the left here. So 5 point, write the other numbers down. And it's always multiplied by the power of 10. And your exponent is just how many digits there were there. So that's going to be the 7th number. So 5.79 times 10 to the 7th. Okay, let's take a look at Venus. Venus, 67,240 miles away from the sun. Let's again start with 0. Remember we started with 0 yesterday. So 0, 1, 2, 3, 4, 5, 6, 7. So again, if you need to, draw that line there. put that little bar so you have one number to the left. So it's going to be 6.724 times 10 to the power of 7. Okay, last one we'll do together here. We have Mars. Same thing. So 0, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put my little line there to separate the last number to the left. So I'm going to come over here and write 1.416. Again, when I hit all these zeros, I can stop. Times 10 to the power, in this case, 8 was the last number, to the power of 8. Okay? So take a look at the next page. Go ahead and do these on your own. It shouldn't really take you very long. Check your answers whenever you're done. Give you guys a couple minutes. Go ahead and hit pause. Okay, so go ahead and take a look at the answers. You can hit pause just to keep this page on your screen so you can check your work here. Okay, again, just to make sure, your scientific notation, only have one number to the left at a decimal point, and it's multiplied by some form of a power of 10. So take a look at the bottom. So go ahead and hit pause just to take a look at these answers so you can do that on your own. Okay, moving on. Now, in this case, we want to go from scientific notation to standard form. So in this case, we're going to make this number bigger. We're going to expand this number so it has more digits. So again, this number is already in standard notation. So we have one number to the left of the decimal point. It's multiplied by some form of power 10. Now, in this case, we're going to kind of work backwards here. So what I'm going to do is I'm going to write 3, 2, 4. And I know I have a 6 as the exponent. So what that means is I'm now going to count backwards. 6, 5, 4. But now I'm out of digits. Well, I'm still going to count 3, 2, 1, 0. So now I need to fill these numbers in above my 3, 2, 1, 0. What do you think I'm going to fill that in with? Yeah, that's right, Kira. Now I'm going to fill that in with zeros. So go ahead, 1. Oops, let me use the right color here. 1, 2, 3, 4. And the last thing, which always seems to be one of the more difficult things, is to put your commas in. So you're going to put your commas in every third digits to the right, just like that. So the final number here is 3,240,000. So let's go over a couple more examples down here. So here I have 5.8 times 10 to the 7th. So I'm going to write 5 and 8 over here. So I need 7 digits. So I'm going to go 7, 6, let me use a different color. 7, 6, 5, 4, 3, 2, 1, 0. And again, just fill in all the empty spots with zeros. Put your commas in, every third digit from the right. So that's 58 million. Okay. Now, take a look at Venus. Now this way I'm going to kind of show you a little shortcut. Again, write down the number that you have. So I'm going to write 108. Now, if you can write, or if you can do two things at once, you can kind of do this together. So I know I need to move 8 spots, or I need 8 digits. So watch what I'm going to do here. I'm going to go 8, 7, 6, 5, 4, 3, 2, 1, 0. Put your commas in. Bam, boom. We got it. So that's 108 million. So let me show you again exactly what I did. So here, down here, I have 1.496. So come on over, write 1496. Start with the 1. I know I got to move back from 8 to 0. So I'm going to go 8, 7, 6, 5, 4, 3, 2, 1, 0. Put the commas in. So again, it's you know, it can be done a little neater. You don't have all those numbers underneath, but you could choose whichever way you want to do it. Okay? So let's take a look at the next page. Go ahead and try these on your own. Hit pause. Check your answers when you're done. Good luck. Okay, so go ahead and take a look at your answers. Again, you can hit pause just to check your answers so you have time to check them. And here's the bottom. Again, go ahead and hit pause if you want to check those. Okay, in part 3, what we're going to be dealing with is very small numbers. So we're going to be dealing with decimals. We're going to write them in scientific notation. Now, there are two major differences here. And the biggest difference is the fact that when we count our numbers, our 0 is going to be to the left of that decimal point. Okay, our 0 is going to be over here. Okay, and then I'm going to count, and I'm going to count once I get to my first number that's not a 0. I'm not concerned about what's after that. As soon as I hit that first number, I am done counting. So let me show you what I mean here. So I start with 0 over here on the left side. Then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Stop when I get to that first digit. So now what I'm going to write is 5.68 times 10 to the negative 8th power. Okay, I'm moving to the right. I have a decimal, I have a very small number, so I have a negative exponent. Okay, so again, the 0 is going to start to the left of the decimal point. Count until you hit that first number. Draw your line so you know that's where the decimal goes. So I'd write 5.68 if there was another number here. If there was like a 7 here, then I'd write a 7 here, but there's not. Okay, so let's go through some examples and you'll catch on here. So take a look at number 1. Here we have this number that we want to write in scientific notation. So again, start with your 0 to the left of the decimal here. So 0, 1, 2, 3, 4, 5, 6, 7. Start when you get to that first number. Then I'm going to write 4.5 times 10. Now please, I know we like to fear our negative signs. Don't forget the negative. This is a negative 7. Take a look at the next one. Now it might be helpful to just go ahead and put the line in first so you know where to stop. So again, you can do 0, 1, 2, 3, 4, 5, 6, 7. So I would write 3.67 times 10, again to the negative 7th. Take a look at number 3. Go ahead and put your line right after that first digit so you know when to stop. Now this time I'm just going to count mentally. So out here is 0. So 1, 2, 3, 4. And that's when I hit the 9. So this one's going to be 9.82 times 10 to the 4th, because I forgot the right numbers. I forgot what number it was. Okay. So go ahead and try the next page on your own, and then go back and check your answers, and go ahead and hit pause. Okay, so here are the answers for 4, 5, 6, and 7. Hit pause real quick. Check your answers. Here is 8 down here at the bottom. Okay, and the last part we're going to look at is we're going to go from scientific notation to standard notation. So we're just going to work backwards. We're going to work back to the left all the way back to our decimal point. So again, it's important to know what the exponent is. The exponent is 4, so that's how many digits I'm going to count. So let's take a look at this. So I'm going to start here. I'm going to count backwards. 4, 3, 2, 1, 0. Now again, the big difference here is the decimal point is going to be located between the 0 and the 1. And what am I going to fill in up top? Well, I'm going to put some zeros there to fill in that. So this final answer here would be 0.00345. Okay, take a look at some examples down here. So I'm going to write 4, 5 over here. I'm going to count backwards to the left 7 times. So 7, 6, 5, 4, 3, 2, 1, 0. Decimal point goes above the 0, between the 0 and the 1. Everything else gets zeros. Yikes. I'll have to work on that one a little bit better. Okay, number 2. 5, 6, 7. I'm going to go back 5 spots. 5, 3, 2, 1, 0. So 0, 0, 0, 0, decimal point. Okay, and then the last one, I'm going to do this underneath. 3, 2, 3, 4. Move to the left 4 spots. So 4, 3, 2, 1, 0. Well, I know the decimal point goes there, so there's your final answer. Okay? So the last thing you guys are going to do is go ahead and work on these last problems. Okay, go ahead and check your answers while I'm talking. The big thing here is to make sure that you count, make sure you have the right amount of zeros that I do, and make sure that your decimal point is down. Now, there are several ways to do scientific notation. This is just one method. If you know another method that's working out for you, feel free to use that, okay? And then also, either today or on Tuesday, we will show you ways to do this with a calculator. All right, good luck, have fun, enjoy.